Okay, so it looks like we have two people watching the stream today, and so for that reason, and also because it's sort of a lot of hard work trying to get this set up. I have to practice and I have to come here and work on the problems. So this is going to be the last such session. I'm not going to have more sessions. I was planning I'd do it for another week, but because there's only 3 or 4 people that are joining in, I'm not going to bother. We'll just stop with this. Okay, so with that said, today also I'm not going to spend any time discussing newer things. I'm just going to finish up this code that we were working on Friday, just so we have some finality. And otherwise I was planning to do some searching and sorting problems, but it's really sort of pointless if there's nobody watching for me to put in that effort. So I won't. I'll just finish this and then we'll stop. So let's recapitulate what we were doing. We were writing a function, or we were writing some code that would input a linked list, and then it would split the list up in alternating manner into 2 smaller lists, and from these 2 smaller lists it would construct numbers based on the digits stored inside the lists, and it would subtract the smaller number from the larger number. So what we had done is we had defined the data structure, the self-definitional data structure, and we had made a bunch of functions to handle basic operations, create a node, input data into a list, and print a list. And then we were working on this function, solve, so actually I should declare these prototypes above also. And this one also. So you can see this is not as straightforward a problem as some of the others we have solved, but we are making some progress. So last time we saw that we were able to get a correct alternating split, and now we have these 2 lists. So remember, we printed out the 2 lists A and B and we saw that they were correct. Now we are going to pass to this subtract lists function a pointer to the first list and a pointer to the second list, and then we are going to subtract. So here we have to handle first the exceptions. If L1 is not set, if it's empty for example, then what do? We will simply return null. There is no result. And then what do we have to do? Well, we have to figure out if they are the same length or different lengths for sure. And if they are different lengths, then we have to handle it. So for this, I'm going to define yet another function. I'm going to say int len1 equals get length L1, and I'm going to say len2 equals get length L2. So I need another function, and this function is going to return the length of a linked list. I'll pass the address to the linked list, it's going to return the length. So I need a function that looks like this. I'll just say list. And so let's say int size equals 0, and then I'll just iterate through the list while list not equals null. Remember, you're working with the pointer to the list, and I'm just iterating through it. List equals list next, and what do I return? I return the size. So this small function is doing what? It is taking the address of the list, it is iterating through the list using the next field of the linked list, and it's terminating when the next field is null, and so it is returning this integer, which is the size of the list. For completeness, let us declare these above also. Now you can see that this has become very bulky, and what VS Code gives you is the opportunity to make your code less bulky. So whatever pieces we're not working on, we can fold. So we're not working on any of these pieces right now. In fact, even this is ready. So I'm just going to fold all of them. So now I've folded my code, and now suddenly it is a lot more manageable. I can see more of it within the screen. So folding is always good. You can see that icon here that lets you fold. Okay, so now I have the lengths of the two lists. And now I can move on. So the next piece of the logic we have to understand is that we have to decide which number is bigger and which number is smaller, because that is how we'll be able to identify which number to subtract from which number. And this is not that straightforward, because first we have to actually extract those numbers. So I'm going to do this in a certain way, and there are other ways to do it, but let me just do it my way. So I'm going to say node left equals null. So this is where I'm going to put the larger. And now I'm going to need a couple of temporary variables. And you'll see what they're for as we go along. So now we have to handle the case where the lengths are not equal. If len1 not equals to len2, then we have to say left equals, and now I'm going to use a conditional operator, len1 is greater than len2, so what does this do? This is a conditional assignment. If len1 is greater than len2, then clearly we have a winner. One of the numbers is bigger than the other. We know without actually having to look at the digits. So we'll just say left equals L1. Otherwise, we'll say L2. And for the other one, that just gets the opposite assignment. So hopefully this makes sense to you. We are trying to figure out which number should be subtracted from which number. And in this situation, one of the easiest things to do is to say that if one of the lists is longer than the other, then clearly that list is going to have a bigger number. And now, in order to do this correctly, we have to do one more thing, which is we have to pad some zeros at the end of the second list in order to make the subtraction work properly. So we will make a function padding. We will pass into it the address of the right list, and we will say len1 minus len2. And this is how we prepare. So we haven't actually subtracted yet. Now we have prepared to handle this condition where the lengths are not equal. Otherwise, if the lengths are equal, then what do we have to do? While L1 and L2. So we're essentially going to iterate through the list, or the two lists, because we know that they are the same length. If L1 data not equals to L2 data, left equals L1 data greater than L2 data, conditional assignment. And now what are we putting in? You'll see why we need the temp variables now. So let me just write this completely, and then we'll talk about why this is reasonable. So, what are we doing here? We are iterating, or actually we haven't yet started iterating, but let's just see what we're doing here. So, we know that the lists are of the same length. If they were not of the same length, then they would be handled within this condition. Now we're working with, let me just like this. Yeah, that's better aligned. Now in this condition where we know that the lengths are the same, L1 data is pointing to the data stored in the first entry in the first list, and L2 arrow data is pointing to the number stored and the first entry of the second list. And we don't yet know which one is bigger or smaller, so this is what we're figuring out here. If L1 data is greater than L2 data, so this is the most significant bit. So if one of them is greater than the other, then clearly we know that this number, the number stored in temp1, which is the same as the one stored in L1, because we assigned temp1 to L1 to begin with, that belongs, or that is bigger, so we assign that to the left list, and the other one we assign to the right list. Makes sense? And then we don't need to go any further in the list. We are done, because as soon as you found the most significant bit not equal, then you can trivially say which one should be the left one and which one should be the right one. Now if they are not equal, then what do you do? So then we go further in the while loop, and we'll say L1 equals L1 next, and L2 equals L2 next. So what will this do? This is going to keep iterating through the list until we find data points that are different, and so that is the one, or so if they are the same in the hundreds place but they're different in the tens place, it will go through the loop 2 times. It will find that the tens place is different, and so it will pick up whichever one is bigger and say that one is left and the other one is right. So that is how we will handle this. Now we know 2 lists that are now we have 2 lists and we know which one is bigger, which one is smaller, and now we just have to do the subtraction. We could do it right here, but because this code has already become slightly big, what I'm going to do is I'm going to break out of this and I'm going to make a new function for this, which will return, I'll just call it a subtraction helper function, and to this I'm going to pass left and right. This is going to return to me the difference. So let me declare this as a prototype also, or actually let me write the function first and then we will write it as a prototype. Let me write this here. Make this compact. Now here, what are we going to return? Ideally we should return an integer because we just want to print out the result, but let's be more general. Let me say it's just going to return an address and then we'll solve it. Fraction helper, is that correct? Yes, this is correct. And what am I passing? I'm passing node star left. I am passing these 2 formal parameters. Just make sure. Yes, that is correct. And now we have to handle the default condition where there's nothing. If left equals null, this is just good practice to handle exceptions up front. Right equals null. So unless you pass the function, pass the arguments properly, you'll get a null result. And now here the logic is going to get a little bit more complicated. So let me just write it and then I will show you what this actually means. But before this, there's something I forgot, which is that when you're doing subtraction, you also need, sometimes you also need to borrow, and we haven't accounted for that possibility yet. So borrowing in a linked list is not trivial. Let's define a variable that will help us borrow. Now this variable need not be very complicated, it can just be an integer, initialize it to 0. However, this also has to go into that function, and what I'll do is I'll pass it by reference. So I have to change this function definition. I'm also sending an address of an integer type here, and then I should check for that also. Actually, let me not bother with this. Okay, so now we can keep going, and I'm going to define something, and then I'll explain why I've defined it this way. I'm going to say the previous value is subtraction helper left oh, actually I didn't pass L1, L2, I passed left and right. So this is what I'm doing. Now what is this doing? Obviously we're using a recursive function. The recursive function is going to iterate through, so let's just think about this. I am defining this as the result of this operation, the subtraction helper operation, and this is going to keep going as long as I have a non-null value for left. And so if there is a non-left value for left, then I'm going to pass to this function left arrow next, which is the next address in the list. Otherwise I'm going to pass null. And similarly for the right, if the right is set to a non-null value, I'm going to pass to this function right next, and the borrow bit is going to keep going in, because this is the address, this is not the actual integer, and so it will keep being updated. We don't need multiple versions of it. So as this call is made multiple times in a recursive fashion, I'm going to pass to the subtraction helper all of these entries, all of the entries of the left list and all of the entries of the right list, one after the other. That's a simple way of doing this, right? We have a function subtraction helper, and now we've defined with it recursively, and because of that recursive definition, the iteration to the lists becomes automatic. And then what do? once everything returns, what do we have to do? Let's say int d1. So now we are actually doing the subtraction. And then to left. And int difference equals 0. So if we have a borrow bit, if the borrow bit is non-zero, this is what we do. We subtract from d1. So remember, we are doing from the left, and then we reset the borrow bit to 0. If d1 is less than d2, we set the borrow bit to 1, and we set d1 equals d1 plus 10. This is in the tens place. So now we've handled two conditions, and now we can say clearly the difference is d1 minus d2. And now what we have to do is, because we are defining this recursively, we need a way of returning all of the results in a list. So that's why this approach, returning a list from the function, is useful. So we'll say node star current equals, and now what we'll do is we'll create a node and store the difference in it. And what do we do now? This is going to bring this whole thing to a close. So this is it. This is how I'm solving the problem of subtracting from or converting the digits stored in two lists into numbers and returning the difference. I have this recursive definition that is going to go digit by digit, and the difference in each of the digits is going to be stored in the current, and then it's going to keep iterating in each recursive call. So it's going to go from back to front. It will handle the least significant bit first, and then it will come to the most significant bit, and it's going to return this list. So now we've sort of completed this, or at least we've completed it in the way that I practiced yesterday. Let's see if this actually works. I haven't defined padding. Yep, that's right. I have to define this also. Okay, so how do we define the padding function? Let's just define it here. So we were passing in a list, and we were passing in the difference in the size between the two lists, and we just have to pad this list with as many zeros at front as there are numbers, or as much as there's a difference between the two lists. So I'll say if list equals null, return null, exception handling. Otherwise, we'll say node star new equals create node 0. And we'll need a temp variable. And then we are ready, because what we'll do is we'll set while diff minus minus, so until diff goes to 0, temp next equals create node, and temp equals temp next. So we have made this small little list temp which stores everything, and this is pointing to the same as the new, and it's just storing as many 0 values as is the difference between the bigger list and the smaller list. And we'll just point this to the beginning of the list that was passed to us. And now what do we return? We return the pointer to the new list. So let's say that the difference between the lists was 3, then I passed in the list and I passed in the integer 3. So I created this new node, and I stored 0 in its data, and now the diff is 2, so it's going to count down 2 and 1, and it's going to create these two new things, and temp and new are pointing to the same address to begin with. And now I'm pointing the next field in temp to list, and new, which is pointing to the same address as the beginning of temp, is what I return. So what I get from this is a new list which has 3 zeros padded at the beginning. Now let's compile it. Okay, this time it works. Now the hour of truth. 1, 2, 3, 4. So first I now have to go back into my main function, and I have to return result. Let me make sure. Yeah, okay. So now let's try and do this again. Excellent. So I returned, or I printed out 11. Now of course I printed out 1, 1. So it's possible to write a function that actually says not 1, 1, 11. But I'm going to leave that for you as homework. You do it yourself. That's not hard. So this is it. We have this function. It's working. Let's try it with something else. 5, 3, 2, 1. So 52 minus 31 should be equal to 21, and it returns 21. Let's try some other cases. 9, 0, 1, minus 1. This should return 91. Yeah, it works. So we had this hard problem, and it took a little bit of time for us to do it, but now you can see how it works, and I'm going to share this with you, and you will be able to work through it on your own and verify that it works. And of course I'm leaving as homework. What am I leaving as homework? Oops. Left as homework, convert result to an int and print. Alright, anybody has any questions about this or anything else? Because we're not going to be talking again. This is the last session. Anybody have anything to say? Well, there's just two of you, and you've been around since forever, so I'm guessing you know that the class started. Yeah, so the class started. I see that there's 11 people watching. Thanks for watching. Hopefully this has given you some a better handle on how linked lists work. As I said, I'm not going to be doing the algorithms problems. I'm just going to share the solutions with you, because it takes a lot of effort for me to get these streams set up, and I don't want to make that effort if it's just 10 people watching. So that's it, and hopefully this gives you a head up for your re-examination. I don't know when the re-examination will be, but it'll come, and hopefully all of you will do well. If you guys have questions, you can ask me, and if it's just the 10 of you asking me, I can easily handle those questions. I can't handle 50 questions, but I can handle 10 questions in a week. Email me if there's something you need to understand better, and otherwise it's goodbye, and I'll see you around.